Okay, guys, listen. Ok, alors nous parlons de ce chapitre-là, basically this chapter, nucleic acids and protein synthesis. Alors, screen page share, all good, sound is good. All right, I can just hide this filter. Okay, good. Alors, nous parlons de ce chapitre-là, guys, nucleic acid et protein synthesis. Maintenant, rappelez bien, quand nous parlons de nucleic acid, nous disons deux, nous vous disons avec deux nucleic acid. Tu as RNA et DNA. Ok, rappelle bien, RNA c'est quoi? C'est ribonucleic acid et DNA c'est deoxyribonucleic acid. Et là, la deuxième partie de ce chapitre-là, nous deal avec protein synthesis. By the way, à chaque fois nous dit, what is the site of protein synthesis? Where does it occur? Yeah, normalement nous dit ribosomes. Isn't it? Ribosomes is the site of protein synthesis. Okay, est-ce que protein synthesis is an energy requiring process? Yes, okay, it is an energy requiring process. Does it require ATP? Indeed, in energy requiring process. That is, it requires ATP en général. Anyway, so the objective describe the structure of nucleotides, même ATP. Although ATP n'est pas un nucléotide, mais because c'est adenosine triphosphate, okay, mais for some reasons it forms part of this. Okay, it forms part of this chapter. Ok, maintenant ne me demande pas pourquoi. That's how it is. Ok, guys, allez, ça va. Anyway. Nous continuons. Okay, let me show you. Alors là, it does it. Bon, which screen can you see? Okay, you can see it good. Okay, yeah, including the phosphorylated nucleotide ATP. Okay, je suis capable d'écrire structure d'un phosphorylated nucleotide ATP. Pardon, did I say it was not a nucleotide? Yeah, so it is a type of phosphorylated nucleotide, guys. Okay, allez. Bon, to start with, guys, RNA, là, DNA, c'est déoxyribo, ribo. Maintenant, le mot déoxy en passant, déoxy veut dire remove. D veut dire, par exemple, déoxygénated veut dire remove. Remove et oxygène, c'est oxy, c'est oxygène. C'est sa différence. En passant maintenant, guys, remember que DNA et RNA, c'est une macromolecule. DNA, RNA, c'est une macromolecule. Veut dire une giant molecule, guys. Okay, I hope is this part clear? Okay, do you guys still remember? Qui veut dire une macromolecule? Qui veut dire ça? Comment veut dire le mot macromolecule? Yeah, what does that mean? Ok, alors nous regardons dans le chapitre 2, ok, biological molecules. Vous obtenez que définition d'une macromolécule, c'est tout simplement une large molécule, such as polysaccharide, protéine ou bien nucleic acid. Maintenant, c'est ce qui nous va guetter là, nucleic acid. Alors, remember, a macromolecule is a giant molecule. Ok, ça mène à trois affaires, polysaccharide, protéine et nucleic acid, qui nous rappelle un polynucléotide. Ok, sugar, polysaccharide. Protéine, polypeptide, nucleic acid, polynucléotide. Mais tout ça là, c'est quoi? C'est une macromolecule, guys. Alright? Et polymer, a giant molecule made from many similar, not same, on va pas dire same. Ok, not same, mais similar. Not same, similar. Ça veut dire que structure en gros similaire. Par exemple, un aminoacide. Right? Structure là similaire. Alors, repeating subunits joined together in a chain. The subunits are much smaller and simpler molecules known as monomers. Example, biological polymers of polysaccharide, protein, and nucleotide. Nucleic acid, pardon. Ok. Et bien sûr, comment se join? Condensation reaction, a chemical reaction involving the joining of two molecules by removal of water molecules. Allez, nous quittons là. Hein, maintenant, nous revenons avec le chapitre nucleic acid. Voilà. Alright. Alors, il va raconter une giant molecule, tout ça. Qui fait lien macromolecule, c'est parce qu'il y a many repeating subunits. Many repeating similar subunits. Ok, guys. Et nucleic acid, because... Oui, maintenant, qui fait le mot nucleic acid là-dedans? Parce que, au fait, le mot nucléique il est relié avec le mot nucleus. Parce que they were originally found in the nucleus. Ok? Et rappelle bien, nous fait get ça de l'autre côté, nous move the page, nous ça que protéine et que protéine aussi et que ban polysaccharide aussi, c'est ban macromolécule. Ça veut dire ban polypeptide et polysaccharide, ban aussi ban macromolécule et nucléic acide, c'est ban poly, c'est ban macromolécule, c'est ban polynucléotide. Alors là, il donne une brief definition. So, macromolecules are polymers are made up from many similar smaller molecules, ça veut dire un monomer, joined together to form a long chain. The monomer from which DNA and RNA are formed are called nucleotides, and DNA and RNA are therefore polynucleotides. Ok, make sense ça? Tout à fait bien simple. Maintenant, quittez ça. Chaque fois, on peut servir le mot nucléotide. Mais pareil, comment là-bas, nous servir le mot, par exemple, monosaccharide. Many monosaccharides are joined to form a polysaccharide, for example. Ou bien, for example, many amino acids are joined to form a polypeptide. N'est-ce pas? Mais pareil ici, qu'est-ce a fait pour join to form a nucleic acid? C'est nucléotide. Nucléotide they join to form a polynucléotide. Mais c'est quoi ça, un nucléotide? Un nucléotide est une molécule qui contient un nitrogen containing base, une ferrant forme 5 by the way at O level it was assessed. A nitrogen containing base, a pentose sugar et a phosphate group. Maintenant, pentose, pent veut dire 5, alors pentose sugar c'est un 5 carbon sugar. Ok, guys? Et polynucléotide, c'est quoi? C'est a chain of nucleotides joined together by? Non. Ok? Là, peptide bonds, là, nous pouvons dire avec un phosphodiester bond. Mais alors le mot que tu as phosphodiester, bien sûr, veut dire qu'il y a une réaction qui peut arriver au phosphate group là. Ok, guys? I hope this part is clear. Nous venons un peu de ça côté-là maintenant. Un nitrogen containing base. Alors, nous trouvons le mot que une structure de l'ADN, ou bien une structure d'un nucléotide plutôt, plus précisément, il contient en premier un nitrogen containing base. Alors, normalement, il y en a 4 différents. Bon, je cas commence pas à faire plus simple là, avant, non? Ah, ok, ici, désolé. Alors, ça c'est mauvais dire. Alors, un nucléotide is made up of 3 parts, 3 smaller components. Ok, pareil que quand tu get protéines, il y a un R group, c'est pas carboxyl group, central, c'est pas quoi, ok, il y en a sur différentes parties, un hydroxyl group, blablabla. Bla, bla. Mais pareil, un nucléotide aussi, il y en a sur différentes parties, il y a un nitrogen containing base, un pentose sugar et phosphate group. Ok, normalement, en gros, nous dessinons une structure comme ça. Ok, il y a un gros sugar ici, qui est sugar, c'est un pentose, en d'autres mots, un 5 carbon sugar. Il y a un phosphate group, et il y a un nitrogenous base. Nitrogenous base. Ok? Ok, guys? Good? Maintenant, en premier, on va get nitrogenous base. Normalement, nous avons 4 différents nitrogen containing base dans l'ADN et 4 dans RNA. Au fait, en gros, en total, dans la nature, existe 5 different. Ok, là, il y a confusion de ça. Ok, alors rappelle bien, dans l'ADN, il y a qui 4 bases, il y a A, C, T, G. Ça, c'est pour l'ADN. Et pour RNA, dans l'ARN, il y a A, C, U, G. The penalty, the RNA penalty. Okay, so in DNA the bases are adenine, guanine, thymine, cytosine. Adenine, cytosine, thymine, guanine. RNA said thymine is replaced by similar base called uracil. Alors penthymine, okay, thymine is disparate and uracil. Alors the bases are often referred to by their first letters A, G, T, C, and U. Ça veut dire en tout il y a 5 bases. Rappelle ça, hein? Mais dans RNA, il y a 4 types et dans DNA, il y a 4 types. 2 of the bases, adenine and guanine, are related to the chemical purine and are referred to as purines. The other 3, thymine, cytosine, and uracil, are related to the chemical pyrimidine, pyrimidine and are referred to as pyrimidines. Purine has 2 rings in its structure. Pyrimidine has 1 ring. Maintenant, qui ça, histoires qu'il vient de raconter là? Guys, listen. Ça bout là, il est bien important vous de comprendre ça parce que beaucoup de questions viennent sur cette partie-là. Surtout, surtout en ce qui concerne comment ça s'appelle? Allez, guys, regarde ça bout là. Can you see my screen là? Ok, good. Let me just hide it then. Allez, alors, bon, en passant, ça c'est bien sûr le syllabus. Le syllabus qui peut dire guetter. Structure of nucleotides. Et, ok, en gros, nous finissons de dire que un nucléotide, il y a une pentose sugar, un 5 carbon sugar, et là, il y a une nitrogenous base, et puis il y a un phosphate group. Ok, guys, good. ATP, nous pouvons l'explorer un peu plus tard. Maintenant, là, nous pouvons get sa partie que tu raconte type adénine, base, blablabla, or purine, double ring structure, cytosine, thymine, uracil, or pyrimidine with single ring structure. Nous pouvons get qui veut dire avant de faire ring structure, c'est pas qui là. Ok, guys? Bon, ça rappelle bien, qui c'est ce qui m'a raté, phosphate group, là, blablabla. Yeah, en passant, c'est un mnémonique, je rappelle thumbs up. Ok, thumbs up dans DNA et na T, dans RNA na U. Et rappelez en fait que sa sugar là, sa pentose sugar là, il y a une reducing sugar. Il y a une reducing sugar qui fait à cause de la présence de ban aldehyde groups, which are free in nature. Ok? Et ça c'est ce structure en gros mais pareil. Et là, normalement, là, il y a un carbone number 1, 2, 3, 4, 5, ça là. Et un peu comme ça. Ça, c'est une pentose sugar, cette structure un peu comme ça. Although, je n'ai pas besoin de cette structure. Ça, c'est un phosphate group. Ça, c'est comment elle est restée. Alors, là, il y a un CH2 group. Enfin, normalement, c'est CH. Anyway. Alors, oui, un peu de ça. Rappel. Oui, en passant, nous disons le mot. Si on a 2 monomères dans ce cas, comme on a 2 nucléotides, ça c'est un nucléotide, ça c'est un autre nucléotide, ça link, ça bandage qui est entre ces 2 nucléotides. Là, il y a une phosphodiester linkage. Un phosphodiester linkage, d'accord? La chose, comment ça s'appelle? Peptide bond, c'est pas qui. Anyway. Oui, en passant, structure de ribose avec de deoxyribose, qui est là, ici, il y a un O. Mais ici, PNAO. Alors, le fait qu'il nous retire NO, c'est ce que nous dit nous dioxygénate. Dioxygénate, ça ribose là. Alors, nous appelons deoxyribose. D'accord? En gros, ça c'est la structure d'un ribose. Sugar. Oui, bien sûr, un ribose sugar. Ribose, lien, 5 carbon sugar, N, D, 3, 4, 5, d'accord? Et base pairing, il y a que dans ce style-là. Ok? Rappelle, et pairs, en première fois que je vous connais, qui s'en a pair ça là. Rappelle, et it pairs with T. Mais dans RNA, et il peut pair with thumbs up. Alors, with you. Et à part de ça, C, it pairs with G. Rappelle, cytosine with guanine, et adénine, il pair soit en thymine dans DNA, ou bien avec uracil dans RNA. Ok, ça c'est les affaires. En première affaire, vous allez connaître Oxana, BSP Oxana. Maintenant, deuxième, vous allez connaître, mais quand l'IBP est arrivé, c'est un hydrogen bonds qui formait entre des bases là. D'accord? Bon, hydrogen bonds, rappelle bien, il formait quand il y a ça 3 éléments là. Mais une bénafluorine, bien sûr, à l'ion oxygène, nitrogène. Ok, bon, un peu plus tard, nous quittons qui fait les former là. Ça veut dire les former en sa base là, get là. Et là, ça va faire là, la hydrogène, nitrogène. Alors, à cause ça va faire là, les cas forment hydrogen bonds avec ben, les autres hydrogènes. Anyway, un peu de ça ici là. Oui, maintenant, mais il faut mes hydrogen bonds. Mais je vous connais que entre adénine et thymine, il y a 2 hydrogen bonds, et quand guanine et cytosine, il y a 3 hydrogen bonds. Ça, je vous connais. OK? Et il y a une façon pour rappeler, vous pensez, en premier base pairing. Rappelle apples on the tree. Alors, adenine, it binds with thymine. Alors, maintenant, je rappelle thumbs up, de RNA penalty, de gain EQ. Deuxième rappel, car in the garage. Alors, cytosine will pair with guanine. D'accord, là, guys? Maintenant, comment je vous rappelle combien hydrogen bonds il y a? Rappelle, thymine commence par T, mais dans T, rappelle T for 2. Alors là, on a 2 bonds. Et C, à peu près que 3. 3. Let's suppose you say 3. There are some people who say 3, no? So C, 3, C. So it's like 3. Okay? Ou bien je can rappelle A, B, C. C is the third alphabet. Isn't it? So there's 3 hydrogen bonds. D'accord là? Alright guys, good. Maintenant, ça c'est le premier affaire que vous avez connu. Maintenant, deuxième affaire que vous avez connu, ça va nitrogen base, une division de type. Il y en a un purines et un pyrimidines. Ok? Bon, pas besoin de connaître qui veut dire pyrimidines, pas qui. Ils connaissent des types de chemicals, ça. Alors, ban purines, il y a une affaire qui s'appelle ban purine et une affaire qui s'appelle pyrimidine. Ban purine, nous avons deux purines, guanine et adénine. Et comment nous identifier eux? Par eux, double ring structure. Il y a deux rings. Vous trouvez? Ça c'est un ring, l'autre c'est des rings. Alors, double ring structure. Ban purine, c'est un double ring. Ok? Et tu as un pyramidine, ben c'est un single ring. Tu dois un seul ring, un seul ring. Qui ça trois, ce là, c'est C, T, U. Cut. Ok? Cut. Alors, rappelle, pyramidine, c'est pi, cut. You cut the pie. Pi, you cut the pie. So, these three bases. C, U, T. Ok? Cytosine, uracil, thymine. You cut the pie. You cut the pie. Now this is a very naughty, yeah. So the site of your thighs makes my pyramid rise. By the way, this is a rhyming word. The site of your thighs makes my pyramid rise. So this is C, U, T, cytosine, uracil, thymine, and pyramid, so pyrimidines. Okay, it's actually read like this: the site of your thighs makes my pyramid rise. Anyway, that's a very naughty way to remember it. And as to what concerns purines, now, firstly, du moment donné apprendre l'autre là, tu finis connaissez qu'il restait les seul en vert, okay? May you may remember this pure has 2 gold rings. Now this one will also help you to remember the number of rings. Okay, this one does not make you remember that. Okay, so nothing pure has 2 gold rings. Nothing pure has 2 gold rings. So pure for purines, 2 for 2 rings, and gold is what? Gold is well, you can remember it as A for adenine and G for guanine. Or gold, the chemical symbol of gold is Ag. No, Ag. No, that's not it. Gold is AU actually, right? No, okay, it's wrong. It's actually silver. Silver is AU, AG. AG is silver. Remember, you've got 2 alphabets, so maybe 2 rings. This might help you somehow to remember it. Anyway, so that's all. Remember, you've got the pi cut. So the pyrimidines are cytosine, uracil, and thymine. And then you've got the AG. AG is the adenine and guanine, which are 2 ring structures, and they are the purines. As pure silver. You can just remember two pure silver, and cut pi. We use 2 pure silver to cut pi. Okay, anyway, so there you go, your two pure silver, your two pure silver, pure silver, and to cut the pie. Okay, and then now go on, all these you've got just thymine, which is found in RNA, and uracil pardon, thymine in DNA only, uracil in RNA only. And remember these two silver, these two silver things, two pure silver. Now you've got also this very interesting one, pure agony, pure agony, 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 pure agony. So Ag is adenine and guanine, and pure for purine, pure agony. Okay, guys, and yeah, so pure agony is two pure agony, and yeah, interesting questions by the way. Why RNA can be described as a polymer and a macromolecule? So polymer because you've got many repeating subunits. It is made up of monomers, which are the nucleotides, and then macromolecule because you've got many repeating similar subunits, like a long chain. Okay. Now we'll take a look at these questions later on. Now we can do these questions to just assess our understanding. Nucleotides are structural components of nucleic acids. Each nucleotide contains pentose sugar, that is our ribose, or deoxyribose, depending, a phosphate group and nitrogen organic base. To compare DNA nucleotides with RNA nucleotides as structural components. So pentose sugar. Okay, so in DNA nucleotide, it is deoxyribose, isn't it? Deoxyribose, isn't it? Here it's just ribose. Purine bases. So what are purines? Remember, two pure silver, right? So Ag, that is components. So it says okay, so it does not specify about difference, because either way there's no difference about the purine. So both have adenine and guanine. Same here, guanine. Oh, it's talking about structure. Um, so it makes it double ring structure. Double ring. And then pyrimidine. So pie cut. You cut the pie. Okay. Here you've got noti. Here, so you've got cytosine and thymine, and here you've got cytosine and uracil. Good, and that's it. And this table is very interesting because it summarizes everything about the type of sugar, basically everything that's different. So you've got ribose, they are deoxyribose, double ring, it means purine, single ring means pyrimidine, and uracil, thymine, etc. Okay, so this is very interesting, and it summarized basically the first point, pardon, rather the second point of the syllabus. Okay, this second point of the syllabus is basically sort of summarized in that table. Okay, so it's very interesting. You may just go through that table whenever you're revising. Okay, guys. Yeah, by the way, it does not mention it implicitly in this point, but it is here, the type of bonding between A and T. So remember, so C is the third alphabet, so you've got 3 bonds. Here T for 2, so 2 bonds. That's the difference in hydrogen bonding. It's actually just the difference is merely due to the number of H bonds, merely the number. And yeah, by the way, we did mention that there are phosphodiester bonds between the polynucleotides. Okay. Now, this thing about three prime, five prime to three prime, etc. This thing is more assessed in the second part of the chapter, that is on the protein synthesis part of this chapter. Again, the protein synthesis part of this chapter. Okay, guys. Now, I don't think. Okay, we've got to explain about DNA molecule. Okay, we'll come to that in a moment. So before I go to the DNA, yeah, there's a very interesting type of question that comes. Okay, it's very prevalent. So yeah, I really suggest you practice these types of questions because these will come time and again. And so the sooner you get a good grasp, you just master these types of questions, the better it will be for you. Okay, so there's very interesting type of question that is mathematical questions where just basically you've got to calculate stuffs. Perhaps you have to calculate bonds or number of hydrogen bonds or number of bases or the percentage of bases. Yeah, basically these two types of mathematical questions that come merely, mostly, pardon, in MCQ paper. That is in the paper one. All right, guys. Let us take a look at this question. How many hydrogen bonds? How many hydrogen bonds? By the way, this is just the questions I'm working right now is just questions that I typically do to strengthen concepts as I'm explaining. But normally I do additional uh, sessions where we take a look only at when we tackle only exam questions that is in worksheets. Okay, but today we're not doing worksheets, I'm doing explanations that are holding the two strands of this section of a DNA molecule. All right, together, how many hydrogen bonds are holding the two strands? Okay, so one thing you need to remember rather is between A and T you've got two bonds, two edge bonds in it. And then between C and G, you've got three bonds, right? In it. So let me put it in different colors. Okay, so for A and T, I'll put it in yellow. So two bonds, two, 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 and two. Okay, guys, and then the other one maybe in blue, so CG. So there you go. This is free bond, so free, 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 free. Okay, guys, then you basically just add those numbers together to get your answer. So 2 2 3 2 3 3 2 3 2 2 3 2 3 2 2 2. Okay, guys. Alors, 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20. Here you've got 20 bonds. Okay, I'm saying 20 bonds. I'm not saying 20 base pairing. Okay, guys? And then 3, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Here you've got 18 bonds. All right, and that'd be 38. Okay, guys, so your answer is 38. All right, so that will be the answer. Okay, guys, so this is a type of questions that come up, and it's better that you know familiarize yourself with these types of questions. Okay, now moving on to our book once again. Okay, yeah, sorry guys. Um, so let's get back to our textbook. Okay, alors. So we've got this thing, okay, we've seen. So you've got this pie. You cut the pie, and then you've got the two silver rings. I don't know. Yeah, something like two silver or something. Uh, pure silver, right? Yeah, it's two pure silver rings. Two pure silver rings. So two rings. So the silver that is Ag, that is adenine and guanine, they are purines and they are double ring structures. Okay, guys, that's it. And then remember AT, so T for two, so you've got two bonds, and then CG, there are three bonds because C is the third alphabet of the well, of the alphabets. Now, pentose sugar, you know that sugars with 5 carbon are called pentoses. Two sugars are found in nucleic acid. Two pentoses are found in nucleic acids, huh? Ribose and deoxyribose. Okay, so two types of pentose. Okay. A nucleic acid containing ribose is called a ribonucleic acid, and one containing deoxyribose is called a deoxyribonucleic acid. As the name suggests, deoxyribose, it is almost the same except by one fewer oxygen atom. So we saw that deoxy, removal of one oxygen. Okay, guys. Good. All right. The phosphate group give nucleic acid their names, their acid nature, their acidic nature. Okay. Yeah. Okay. Look at the structure of the nucleotide in figure 6.2. Where is it? Where's the structure 6? Okay. Yeah. And by identifying the sugar and the base with label, in each case draw a nucleotide that can be found only in RNA. Okay, so by the way, it'd be like this. So this thing, it could be U C T or U C A or G, and then this would be your ribose for the for RNA, and this would be your phosphate, and then for there it's just going to be the same, almost the structure, where this is going to be deoxyribose, and this would be your ACTG. It could be ACTOG. Okay. The structure of ATP. Now coming to the structure of ATP. Guys, listen. Although ATP is not part of DNA or RNA, you will look at structure here because it's also a nucleotide. So remember, ATP is also a nucleotide. Okay, I got confused myself at the start of this lecture where I was saying that ATP is not a nucleotide, but yeah, just a confusion. Anyway, now continuing, the structure of ATP is shown. It has three components: the adenine, ribose, and phosphate. Adenine plus ribose forms a sugar base called adenosine. Adenosine can be combined with 1, 2, or 3 phosphate group to give in turn adenosine monophosphate, adenosine diphosphate, or adenosine triphosphate. Now, are we able to catch what I'm trying to say? Guys, are you able to catch? Let us see a diagram to understand it better. You remember we had 5 bases in RNA and DNA. We had normally A, C, T, G, and U. That are the 5 bases that exist naturally. But in ATP, we won't make use of all those. ATP comprises of adenosine base only. Okay? And the adenosine, normally ATP stands for adenosine triphosphate. So it contains adenine, and phosphate and a ribose. Okay, now this is your ribose sugar. By the way, ribose, what type of sugar it is? It is a pentose sugar. Do you agree? It's got adenine. Adenine is a type of nitrogenous base. Do you all agree? And then you've got phosphate here attached to it. Now, if it's got one phosphate, you'd call adenosine monophosphate. If it's got two phosphates, you'd call adenosine diphosphate. And if you've got three phosphate, you'd call it adenosine triphosphate. Is this clear, guys? Is this clear, guys? Right? Now, again, I'll clear one doubt. This part, the adenosine plus a ribose, how do we call this? An adenosine plus a ribose? Adenine plus ribose, pardon. We call it an adenosine. Okay, guys. So do not confuse adenine with adenosine, which is part of the name ATP. Adenosine is adenine added with a sugar. And do not confuse thymine with thiamine. Thiamine is a vitamin. Okay, guys. Is this clear? Yeah, we have not yet dealt with thiamine, but yeah. Thymine and not thiamine. Now, dinucleotide and polynucleotide, guys. Now, di means 2. Do you agree? Di means 2. And poly means greater than 2. Greater than 2. Okay, guys. Now, two nucleotides can be joined together by condensation. So, how do nucleotides join? By condensation reaction. Where what happens? What happens in condensation reaction? Removal of water. Do you agree that it is the removal of water? Good. Now, the molecule formed by joining two nucleotides is called a dinucleotide, and you can see it in picture 6.4. Where is it? Yeah. So this structure here, you've got what we would call a dinucleotide, because it's got two nucleotide subunits. Okay, and this linkage here is what we would refer to as a phosphodiester bond. Okay, guys, we'll read into that. So the molecule formed by joining two nucleotides is called a dinucleotide. Okay, guys, dinucleotide means two nucleotide units. The bond form is called a phosphodiester bond, and the term diester is used because the phosphate group involved have now two ester bonds. Why are they called phosphodiester? Because there's two ester bonds. So one bond between two nucleotides. So one bond between two nucleotides is equal to two ester bond and is equal to one phosphodiester bond. Okay, so because the phosphate group involved now has two ester bonds, one to each of the sugar is connected to. The process can be repeated to several to make a polynucleotide, long unbranching strands of nucleus. So this is interesting, the word unbranching. Remember that there's no branch to it. And the sugars and phosphate are linked by phosphodiester bonds to form a backbone. So that's why we call it sugar phosphate by backbone. Okay, blah blah blah, at right angle. So, from which bases stick out sideways at right angle to the backbone. Okay, right angle to the backbone. A bit of this structure of DNA. Okay, okay, not too interesting. It's not too, required these parts. And this would be your polynucleotide. Blah blah blah. Okay, guys. So the first part we are done. More almost done. Almost done. Why? Because I'm gonna have to show you something more. Okay, I'll show you something. Um, Something interesting that's required. Okay, guys, I'll show it to you here. Okay, so a condensation reaction, that's how a condensation reaction occurs, guys. Okay, that's how it occurs. So, um, a moment, please. I need some blank pages. Okay, that's one thing I wanted to show you. And then there's another thing I'll show you. Give me a moment. Hmm. दो कदम तुम भी चलो, दो कदम हम भी चलेंगे, दो कदम तुम भी चलो, दो कदम हम भी चलेंगे, ला 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 la 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 Ok, alors il y avait ces deux choses-là que j'avais à vous montrer. Guys, listen, regarde. Alors, how does a alors, il disait que comment les joints de forme polynucléotide, c'est une condensation reaction. Ok, mais là, alors ça, je vais trouver, il y a une normal structure de un... bien sûr, je ne pas besoin qu'une structure américaine d'une autre. Alors ça, c'est le pentose sugar. En gros, actually, ça, il y a nous vais trouver un single ring, alors nous ne va pas vraiment dire c'est quoi, alors c'est un pentose sugar. Nous va connaître les ribose ou bien déoxyribose. Ça, c'est un phosphate group. OK? Et là, ça hydrogène ici, là, qui peut arriver. Ça hydrogène ici, là, qui arrive. Alors, ça, c'est carbone number 1, 2, 3. OK? Ça, carbone number 3, là, ça hydroxyl groupe qui est attaché à sa carbone number 3, là. Hydrogène, ce hydrogène, hmm, ensemble avec sa phosphate, là, ce OH, doit réagir. Bon, basically, c'est form water. Et puis, mais ça linké là, entre sa oxygène là et sa phosphate là ici. C'est quoi là? Ça on appelle ça une phosphodiester, enfin plutôt il y a un ester linkage. Mais là, ça linkage là en lui-même, on appelle ça une phosphodiester linkage. Ok, une autre photo. Euh, pas condensation, non. Ok. Alors, ouais, ça OH là, et que ça H là réagit. Oui, c'est ce qui me dit. Normalement, ça OH ici là, il pas réagir. Ça O là, il reste pareil. C'est ça O là qui allait. Ça O là, il reste pareil. Les photos là, les wrong. Normalement, 2011, Pearson, tout. Alors, il supposé un affaire qui est accurate, mais alors, yeah, it creates confusion. Normalement, vous avez tout le day dans OH, tout le day dans OH, mais nous avons juste pour former un H2O. Nous avons juste pour former un H2O. Alors, H là, pas matter. Nous prenons un H ici, nous prenons un H ici. Maintenant, ça, alors, de finir de H2 là, mais ça, oxygène là, depuis que ça n'a tout, prend depuis que phosphate là, ou bien depuis que ça, pentose là. Ok, tu prends pentose là, sur oxygène, ou bien ça, phosphate là, sur oxygène. Normalement, ben, ça, phosphate, ça, radical là, ça, qu'on appelle ça, une polyionique, polyatomique, ion, je sais pas qui là. Li, ce oxygène nous prend, ou bien l'autre. Là, normalement, li est beaucoup plus stable. Alors, li bizarre ce oxygène. Alors, c'est pour cela que normalement, nous pas prendre ce oxygène. Nous dire que c'est oxygène là, c'est aussi depuis ici. Alors, ça diagramme là, bon, c'est à revoir vraiment, mais bon, although il pas matter si jamais puis je dessine une condensation reaction. Il pas matter, je pas pouvoir le montrer depuis que ça se fait oxygène là. OK? Yeah, tu dessine ça, tu as un point normalement, juste pour sa final drawing là. OK? That's all. Juste besoin connecter, tu as besoin de tirer 1H2O. OK? Ou rappelle que 1 phosphodiester bond formation of 1 phosphodiester bon. Alors moi écris formation of 1 phosphodiester bond results in the removal of 1 H2O molecule. Okay, very important part. Allez, un peu de ça. Alors, là, il montre que ici, il peut oxygène, hydrogène là, ici, et ça, oxygène et hydrogène, il peut ici. Ça veut dire ça, phosphate là, ce oxygène, il peut pas tout il peut laisser en place. Là, tu gagnes ces affaires là. Ok, bon, vous avez un oxygène ici. Il pas mettre d'oxygène là. Parce que phosphate, veut dire, bon, un phosphate, il besoin ce 5 bonds. Ok, ce maximum bond, normalement, c'est 5. Alors, N bond ici, N, D, 3, 4, 5. Alors, 5 bonds. Ok, guys. Allez là. Maintenant, quoi d'autre? Oui, maintenant, nucleotide pairing. À chaque fois, on va dire A bind with A with T, double bond, C with G, triple bond. Mais qui fait ça? C'est à cause, bon, bien sûr, nous connaissons qu'il y a un hydrogène bond dans ça deux là, n'est-ce pas? Pour un hydrogène bond, et on dit entre A et T, il y en a 3, il y en a 2 bonds. Rappelle T42 and C43. C43. Alors, au fait, d'avoir un hydrogen bond, à cause hydrogen bond qui est responsable. Mais hydrogen bond là, côté était là. Regarde là, ça c'est au thymine, ça c'est au adénine. Rappelle, adénine c'est tout, qui nous dit 2 pu silver. 2 pu silver. Alors c'est Ag. Alors adénine, il prend un double ring structure. Alors regarde là, hydrogen bond là, quand il forme ça oxygène là, et ça hydrogène là. Quand when one of the hydrogen is bonded to nitrogen, alors quand hydrogène là, il est bonded avec nitrogène, oxygène, ou bien oxygène, quand un de hydrogen is bonded with hydrogen ou bien oxygène, et là aussi, oxygène là is bonded to one of these elements, là pour un hydrogen bond. Même ça fait ici. Nitrogen is bonded, hydrogen is bonded with nitrogen. Là, il y a nitrogen. Pour un hydrogen bond, parce que hydrogen bond it must be bonded with something. Quelque chose. Et même ça fait ici, bonded NH, ici O, hydrogen bonds. NH, bond. NH, oxygen bond. Good luck. Alors, get une structure par exemple plus en détail, sort of. Pas exactement. Allez, anyway, NH, vous bind avec N. OH, bind avec N. NH, O. Good là. Alors, là, on a 3 bonds. 3 bonds, c'est quoi? Ça qui forme 3 bonds, guys. Ça là qui forme 3 bonds. Yeah. No. C43, guys. C43. Ok. Alors, CNG. Et ici, il a même fait NH. NH forme ça. Aïe, ça là, il. Pas ici. Okay. Là aussi. Alors. Là. Ok. Il là. Ok, là. Good. Allez, un peu de ça. Maintenant, savant équilibre raconte. Et nous y allons toujours sur hogging electrons. Hydrogen bonding to help stranded nuclear pair. Ok. Base pairing. Ça c'est AT. Ça c'est CG. Ça c'est 3 ici 2. Alors, nitrogen et oxygène c'est électronégatif. So they hog the electrons. They just share in polar covalent bonds. Okay. So, and it hogs some of the electron in this bond. So, nitrogen partly, and the hydrogen is partly positive, partly negative, okay, c'est ça. Partial charge. Guys, good. Mais là, pour une attraction, ok, et ça c'est, ok, etc. Et c'est ce qui purine tout le temps. Rappelle tout le temps que N, oui, ça c'est une affaire très intéressante que N purine always pair with pyrimidine. Purine always pair with pyrimidine. Ça c'est une affaire ajoutée. Ok. On va mettre là. On va mettre là. Rappelle ça tout le temps. Purine. Purine. Always bond. So one purine always bond with one pyrimidine. They don't bond with each other. No, purine va exister. Pyrimidine va exister. Ok. Un peu de ça. Nucleobases are hydrophobic. So they pair up at the center of the, yeah, whatever. Yeah, so that you have an even width, follow. Yeah, even width. Ça, il pas even, ça, il pas even. Okay. Ok, guys. Alors, nous avons une structure de nucléotide là. Nous avons une structure de ATP. Nous avons adénosine monophosphate parce qu'il y a une seule phosphate. Nous avons adénosine diphosphate et nous avons adénosine triphosphate. 2 phosphates, 3 phosphates. Qui nous connaît l'adénosine, guys? Il y en a adénine. Adénine plus ribose, les formes structure qui nous appelle une adénosine. C'est quoi adénosine? C'est adénine plus ribose. Ok, saisis, c'est un point plus important là-dedans. C'est une affaire à ne pas confusionner, à ne pas oublier sur aussi non plus. Ok, à ne pas confusionner et à ne pas oublier. Très important, ça bout là. Adénosine plus ribose, il forme un adéno. Qui me dit là? Adénine plus ribose, il forme adénosine. Ok, ah là. Good. Okay. A further structure Sparky is not needed for this chapter. Le Lavinent chapitre respiration, moi pas trop rappeler ce qu'il doit et tout ça ou quoi, mais chapitre respiration, là-bas, je peux apprendre adénosine, sur comment les casser, ranger, tout ça là, un peu plus en détail. Ok, guys, allez, un peu de, c'est tout là. Alors, premier point, nous fini. Deuxième point, nous fini. Troisième point, bon, nous connaît que des hydrogen bonding, nous connaît que linking of phosphodiester bonds, nous connaît une condensation reaction that join the nucleotides together. Okay, condensation reaction joins the nucleotides together. Okay. Et nous faisons comme ça s'appelle là. Mais ça, je vous comprenez un peu plus bien quand nous faisons l'autre section de sa chapitre là, actually. Ok, quand nous faisons l'autre section de sa chapitre là, les vous comprenez plus bien. Ok, mais une affaire à surtout ne pas oublier, c'est oui, une question qui vient qui est assez prévalente. C'est le côté, à chaque fois, les bouteilles, c'est eux, là, ça va faire reducing sugar là. Bon, normalement, de papier 2, le fait qu'il n'est pas mentionné explicitement dans nos syllabus, alors, dans papier 2, normalement, il y a petit fini mentionné. Par exemple, vous êtes alien reducing sugar, il y a petit fini mentionné. Mais dans papier N, il n'est pas exactement mentionné. Alors, expect nous pour déjà connaître que DNA, the sugar component of DNA, est reducing sugar. Ok? Alors, on peut dire ça. Yeah. Alors, c'est tout ce que je disais. Que rappelle bien qu'une DNA molécule est reducing sugar. Ok? Moi, je rappelle, est-ce qu'il dans livre, il mentionnait que DNA il y a une reducing sugar? Parce que, bon, si dans chose, il m'était bien mentionné ici aussi, là. Euh, reducing. On va vérifier ça là, guys. Okay, guys, let's take a look with it with me together. Alors, c'est qu'il m'a fait trouver qu'il n'est pas explicitement mentionne le fait que il y a une reducing sugar, mais regarde ça. Il y a certaines affaires là, hein. Une minute. Ok. Alors, vous pensez, zut qui vous incapable de faire ça linkage là. Regarde. Il commence par dire zut que nous causons monosaccharide. Monosaccharide, c'est quoi? C'est un sugar et dissolved, blablabla. Et dans différents blablabla. The main type of monosaccharide, when are classified according to bon, number of carbon, tu gagnes triose, pentose. Mais pentose, c'est quoi? Tu gagnes ribose et dioxyribose. Là, tout common pentose, ribose et dioxyribose. Mais c'est quoi? L'indicateur, ben, ça veut dire ribose et dioxyribose, c'est pas une monosaccharide. Do you agree, guys? Do you agree? Yeah. Maintenant, un peu plus tard, il dit ajoute que... minute là, hein? Il dit ajoute un affaire. Il dit ajoute, the reducing sugar include all monosaccharides. Ça veut dire qui se ribose, qui se deoxyribose, both are reducing sugar because both are monosaccharide. D'accord? Alright, guys? Clear? Ok, là. Allez. Ok? Alors, revenons maintenant à notre slide here. Moi, pour remettre les par ici. Rappelle une affaire que I just googled it, by the way. Here you go. Let me put it in a new page, actually. Cut. Alors, très important. Ayo. I pasted it as that. Ok. Non, vous allez comprendre. Ok. Alors, elle a une affaire rappelle que ban monosaccharide. Il y a trois types de monosaccharides. Tu as une hexoses, like 6 carbon, like C6H12O6 glucose. Tu as pentoses avec 5 carbone comme ribose et déoxyribose. Et puis tu as trioses, 3 carbone comme fructose et bon, j'ai oublié, excuse-moi. Ok, triose comme fruct. Il va mettre l'exemple de triose, actually. Ok, fructose, galactose, c'est ben hexose même. Fructose, galactose, c'est ben fructose et galactose. Ok. Bon, quelque chose, un point très important à retenir, c'est le fait que. C'est record là, non? Allez, laisse-moi hide ça. Ok. The all are reducing sugars. Le fait que tout ban monosaccharide is reducing sugar et que ribose, deoxyribose, c'est ban monosaccharide, therefore they are reducing sugars. Ok? Alors, point là, fini là. No further debate. Ok? No further debate. C'est tout, c'est fini, c'est là. Ok là, guys. Right? Allez, probablement nous avons quelques questions encore, non? Surtout... No, I mean, it would be tiring là, to go faire encore partie de ce chapitre-là. It would be tiring. Et l'autre jour, nous get l'autre partie. Parce que l'autre partie-là, quand même, un whole 180 degrés spin, ça. Ok? Alors, c'est qui nous peut actually faire. Il y en a fait qui est un peu totalement un peu différent. Il y en a un autre flow, ok? Ça, l'autre section-là, il y en a un autre flow en lui-même. Ok? Il n'est pas autant simple, aussi simple que ça ne va. En passant, il y a un coin d'affaires qui s'appelle le Shawgat's Rule, qui me pensait pas besoin de faire là, hein? Probablement. Enfin, nous avons fait l'autre jour, Mogeti là, Mogeti, give me a moment. Et là, c'est que vous voyez probablement c'est un MCQ. I'm trying to find an interesting MCQ for you. Give me a moment. I'm really trying to find an interesting question, guys. So you give me a moment. Okay, I think I'm just gonna choose a random one. Okay, so firstly, I've got a 2019 question, which is the 18th question. Give me a moment. A moment, guys. A moment. No, seems incorrect. Okay. Very sorry, guys. We'll take a look at this question. And then another question as well. Okay, so which statement correctly describes the base pairing? What do we know about base pairing is that A binds double bond with P and C triple bond with G. Where T for 2, so Now remember pi cut, right? So for pi cut, so C and T, they are pyrimidines, and then you've got two silver, okay, two pure silver, where pyrimidines are Ag, so adenine and guanine, they are double ring, the two rings, okay. So T is single ring, this is double ring, double ring. G as well is double ring, okay. um where A is a purine, G is a purine, T is a pyrimidine, C is a pyrimidine. Okay, C and T. The purine adenine is a purine, correct? Adenine is a purine, correct? Cytosine is a purine, wrong. Guanine is a purine, correct? Form bonds with the pyrimidine. So remember, purine, pyrimidine, purine, pyrimidine, purine, pyrimidine. Okay, good. Pyrimidine, thymine. Yeah, I mean thymine is a pyrimidine. Uracil is a pyrimidine. Guanine is not a pyrimidine. C eliminated. Thymine is a pyrimidine. Okay, so adenine is with thymine, so AT. AU. Yeah, so DNA is no uracil, so eliminated. A guanine is not with T. Okay, guanine bonds with G, so answer is A. Okay. Which statements about complementary base pairing are correct? So here does not implicitly mention whether it's about RNA or DNA. So let us see. It allows translation to occur. Now, since we have not done this, let us see if we can work it out without knowing this part. Purines and pyrimidines are the same size. No, we saw that pyrimidines are actually single, these single ring structures. So single ring, and purine are double ring. Okay, so they are not of the same, so wrong. So wherever there is two, it should be wrong. So no A, no D, no A. Now okay, so no, pardon, same size. Okay, the base pairs are of equal length. The base pairs of equal length. Now, by the way, 4 is absolutely should be correct because both of them have it. Uracil form double bonds is correct. Now, 3 is what's going to help us. Now, the base pairs are of equal length. What does this mean, guys? So, this is a base. Let's suppose it is A, and A would be what? Double ring, right? And then this is T. T would be what? A single ring, right? So obviously they are not of the same size. And this would form two rings. Do you agree? The base pairs, what does it mean, the base pair are of equal length? Does it mean this? The pairs, so this is a pair. Another pair could be CG, C bonding with G. Here there will be three bonds, but G is what? G is double ring and this is single ring. But it should be this pair, this is not the pair. Do you agree this is not a base pair? It's still of the same equal length. Do you agree, right? So it is absolutely 3. Okay, so 3 should be correct. Answer B. Okay, guys. So, but I'm gonna check the answer for the sake of not propagating misinformation. 18 and 19, right? Okay, 18 and 19, A and B. B correct. Okay, so answer is good, and there A is correct. Good. Okay, you see. So this is a bit of method of how we work MCQs. Very interesting. Okay, guys, you want to work one more? One more question, huh? Um, so these ones are actually quite recent questions, honestly. So yeah. Let us take a few more questions actually. Let us take a few more questions. So it'd be 2018. 2018 November, paper 1. QP1, it's actually 12, the paper 12. And 23 and 24, question 23, 24. Okay, guys, I'm gonna take it separately. Okay, there you go. And then 24. There you go. All right, guys. So let us take a look at this question. So what is the? Okay, give me a moment before I drink my. Just gonna take a little water break. So what is the maximum number of hydrogen bonds? So just this part, why does it say the maximum? Because you've got two types of base pairing. Okay, you've got two types of base pairing. You've got one that has two hydrogen bonds, and you've got one that has three hydrogen bonds. Do you agree? Which one form two hydrogen bonds is A with C, and three hydrogen bonds C with G. You agree? But if you're talking about the maximum, which one would give you the maximum hydrogen bonds? Is this one, right? Three, because three is more, the maximum. So yeah. So what is the maximum number of hydrogen bond in the length of DNA containing 700 base pairs? Now, when would you get the maximum number? So you need to generalize it. You need to generalize it. This would happen if and only if and only if all base pairing was to be CG. That is three hydrogen bonds per base pair, right? So one base pair would be three bonds, therefore 700 base pairs would be 3 into 700, that is 2100 base hydrogen bonds, right? So this would be your answer. Good. That's a simple proportion and simple logical thinking. Next question. What is the common component what is the common component of the three molecules RNA, DNA, and ATP? So you've got A, and A. By the way, here, A stands for adenosine, by the way. Okay, but adenosine means adenine plus ribose. Now this one has ribose, this one has ribose, but this one has deoxyribose. So it's not ribose. Not of all of them phosphates. Typically the structure is like this. So you've got a nitrogenous base and then you've got phosphate here in it. So phosphates. But yeah, You've got a phosphate group. You don't have phosphate. Okay, and no hydrogen bonds. So the answer is no. Wait. Adenosine. Ah, okay. It can't be adenosine. So the answer should be phosphate. Okay, yeah, because if they have phosphate group, then obviously they do have the phosphate, the element phosphate in them. So this structure of ribosome of RNA is like this, structure of DNA is like this, and ATP is similar, but it's got its three phosphates, but the phosphate is still here. So the answer is C. Okay, guys. So the answer is C, phosphate. Okay. There are loads more of interesting questions, but it would take more time to complete all of them. So, yeah, perhaps we take a look at these in a when we work out a worksheet or something, then we take a look at this. Otherwise, for now, we are done, guys. For now, we are done here. And yeah, that's it. Et on se voit très prochainement. Au revoir.